with number sequences, there are several things that you can try. The first thing is try a single operation, which is the easiest thing, which means either add, subtract, multiply, or divide. If we look at example 1, 9.5, 11, 12.5, there's just enough information for us to continue this sequence. 9.5 add 1.5 is 11. 11 add 1.5 is 12.5. So the most reasonable thing to do is to add 1.5. So the next two numbers in this sequence would be 14 and 15.5. Try the same thing with example 2. 2, 6, 18. It's not as straightforward. The numbers get much bigger more quickly. So you could look at it as an adding sequence, but I would tend to think of it as a multiplying sequence. Let's try it both ways. To add 4, then add 12. Now it's not completely obvious how much to add next. We could guess and we could probably work it out, but it's easier to try it as a multiplication. So 2 times 3 is 6, 6 times 3 is 18, and 18 times 3 is 54. So I would do it by multiplication in this case. And then 3 times 54, 162. Now, we could have done that as an add, but it's more tricky to do. If you added 4 and then added 12, what do you add next? Well, the second time, we added 3 times as much as the first time. And if we add 3 times as much again, so instead of adding 12, we add 36. That does work. And then 3 lots of 36, which is 108, added on to 54 makes 162. But that's more tricky to do, and you may get it wrong without realizing. So it was better to do it as a multiplication sequence. So I'll make a note that this one was most simply done as a times 3 sequence. And this one simply add 1.5. Now, in both cases, the same thing happens every time. So whichever operation we're performing, we just perform exactly the same operation each time. Something changes here in example 3. 79 to 72 is subtract 7, and then 72 to 64 is subtract 8. So what's the thing to do next? Well, we continue in that same way, and since it was minus 7 and then minus 8, the most logical thing to do is to subtract 9 in the absence of any other information, and then to subtract 10. So 64 take away 9 would be 55, and 55 take away 10 would be 45. So first we tried a single operation, which worked in questions 1 and 2. Then we tried a changing amount. So here the amount that we're subtracting is actually increasing by 1 each time. In example 4, it's a different pattern again. From 103 to 98 is subtract 5. And then from 98 to 49 is subtract 49. So straight away, I would think, well, rather than subtracting 49, that's halving 98. So that gives me a clue that this may not be the same operation all the way through the sequence, but that it is alternating, i.e. one operation, then another, then back to the first operation, then back to the second. So let me try that now. It's subtract 5, then halve or divide by 2, then subtract 5, then halve, then subtract 5, and then halve. So that comes out 22 subtract 5 would be 17, and half of 17 would be 8.5. So what we've just discovered here in example 4 is alternating operations. So one operation, another, the first operation, the second, and so on. Okay, let's look at number 5 now. We notice here there's something different that hasn't occurred in examples 1 to 4, which is that the numbers get bigger and then smaller. That didn't happen in any of the other sequences. They only went in a single direction. All of them. This one went smaller. This one also went smaller. The first two got bigger and bigger. But this one goes bigger and smaller. So that's a new thing. Now, whenever that happens, it's one of two things. Either it's two sequences mixed together, or it's alternating operations where one operation enlarges and the other operation reduces. So whereas here we had both operations were reducing operations, subtract and divide both reduce. That's why the sequence went in a single direction. But here it doesn't go in a single direction, so we've got two things we could try. So let's try one of them, which is to skip. I would first try the skip just to see if it makes it very simple. A skip is a way of separating out two sequences. So I would say from 5 to 11 to 17 to that one. So that would be plus 6, and if it is a skip, a plus 6 again. And the other sequence is there, which I have no reason to assume there's any error here. It seems like a simple skip. Plus 6 for that. So 5 and 6, 11 and 6, 17 and 6, 23. And for the even position numbers, it's plus 4. And in the absence of other information, I would assume it's plus 4 again, making a 20 here. So here, I used a skip. So remember, a skip is just a way of separating out two sequences. So these numbers, first, third, fifth, seventh, are one sequence, and the second, fourth, and sixth are a separate sequence. Here, same thing happens. Smaller, bigger, smaller, bigger. Now again, I could try the skip. 15, add 9, and then add 27. Well, I think we know what we could try. We could do it as an adding sequence, and we can say, well, we added 9, then we added 27, so now we need to add 81, because we're tripling what we're adding. So that might work, but I'd rather not do it by adding if I can help it. And then the other one would be 8, add 9, and presumably add 9. But I want to check this a different way. I could do it as 15 take away 7 makes 8, and then 8 times 3 is 24, and 24 take away 7 is 17, 17 times 3 is 51. That seems to work, so I would rather do it that way. So 15 take away 7 makes 8, 8 times 3 equals 24, 24 take away 7 makes 17, 17 times 3 makes 51. Now I want you to notice that because subtraction is a reducing operation and multiplication is an increasing operation, it causes the sequence to get bigger, smaller, bigger, smaller. So repeating the alternating pattern, I'd say subtract 7, so 51, subtract 7, 44, and then times 3, 132. So that was another example of alternating operations, as was question 4. So recognizing these kinds of patterns and obviously having good mental arithmetic skills will allow you to solve number sequences. Just bear in mind that when you do have a mixture of sequences, I showed you an example where two sequences are mixed together, but it is possible for any number of sequences to be mixed together. You could have had, for example, 3 sequences mixed together. The more complicated the sequence is, the more numbers you'll have, and it'll be quite obvious if you do have 3 sequences. Now, these techniques won't help you very much with the last set of examples because these are special numbers. And with special numbers, it's just a matter of knowing and recognizing these numbers. Let's take these numbers, see if you recognize them. Okay, you probably do. These are square numbers, and they are consecutive square numbers. Consecutive means occurring one after the other. So we haven't missed any square numbers in this sequence. So 16 is 4 squared, 25 is 5 squared, 36 is 6 squared, and therefore this should be 7 squared and 8 squared. So solving this sequence, we could have done it by adding, but it's better to recognize them as square numbers. So this is 7 squared, and this is 8 squared. I said you could do it by adding, and you can, because you could say 16 to 25 is add 9, and then 25 to 36 add 11, and then add 13, and then add 15, and so on. So you can do it by adding. What about these then? Less common, but you should still recognize the first few. These are cube numbers. That is a number times by itself and then times again by itself. So 1 cubed is 1 times 1 times 1, which is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3, which is 9 times 3 again, which is 27. So consecutive cube numbers. So this should be 4 cubed. 4 times 4, 16, times 4 again, which is 64. And then this would be 5 cubed. 5 times 5 is 25, times 5 again, 125. So recognize those. Now there's one more, which is not a special type of number, but it is a special sequence which you may come across, so I just want you to be aware of it and look out for it. And it goes like this. Now here you've added nothing, you've added 1, you've added 1 again, then you've added 2, then you've added 3. And there doesn't seem to be a regular pattern of adding that you can continue. Times 1, times 2, times 1.5, times 1 and 2/3. Multiplication doesn't work, and yet it is increasing. So we've tried adding, which is an increasing operation, and multiplying, and neither of them seems to have worked. That's because it's a special sequence. What happens here is that the previous 2 numbers add up to make the next number. So look out for that. The previous 2 numbers add up to make the next number. The first number is 1. There's nothing before it, so it's just 1 plus nothing. There was nothing there, so that makes 1 again. Then the previous 2 numbers are 1 and 1, so they make 2. That's where the 2 comes from. Then we take the 2 and the previous number, which is 1, that makes the next number 3. Then we take the 3 and the previous number to make 5. And then we take 5 and the previous number to make 8. So to get the next number, we take the 8 and the previous number 5 to make 13. And we take 13 and the previous number 8 to make 21. So that's an unusual sequence which you may come across and you should recognize. And it won't necessarily have those numbers, but it will have that pattern.